You gotta really pay attention to the directions here. There's a lot of finesse to this whole thing. You will be unsuccessful if you're unable to follow directions. So if you ad-lib this thing, you decide to get creative with it, you don't pay attention. I've had students in other classes, for example, like in capstone chemistry, with things like this that have taken literally 20 or 30 attempts to get it, and then made the comment to me later, oh, I should have followed the directions. Okay, so that is word up to you. I'm going to take you through and show you all of this, but you're going to need to pay attention to what you're doing. Now, safety-wise, you're utilizing 3 molar nitric acid in this, all right, which is a relatively high concentration of this. If you get that on your clothes and whatnot, it's going to burn holes in them. All right, so this is a lab where you may want to be wearing the baggy shirt. You definitely need to have eye coverage. You're also going to be using 6 molar hydrochloric acid, which is a relatively high concentration of HCl on the laboratory bench. All right, so again, you need to really be careful with this stuff and pay attention to what you're doing with it. You're also going to be using a centrifuge, which I'm going to train you how to use this morning, and you're going to be using Eppendorf tubes, which are called Epp tubes in the directions. All right, they're called Epp tubes in the directions. All right, and you're going to need to pay attention to what how the setup works. So you're going to need to get yourselves a little beaker like this one. This is a 40 ml beaker. It was washed. You're going to need to wash it, and then you're going to need to rinse it with tap water, and then you're going to rinse it with distilled water. And you can see I have it full, and it's full of distilled water. You're going to need it full of distilled water because you're going to use the same pipetter over and over and over again. You're not going to be using a brand new pipetter for every single step. So what you'll be doing is filling the pipetter and then dispensing into the sink to rinse it out. 1 or 2 rinses is more than enough to clean the thing out. You're going to need a couple of test tubes for this. Let's see what happened to my test tube holders. Can one of you guys hand me a holder, please? Thank you very much. You're going to need a test tube holder, and you can see that I have another beaker here, so that you can just set this in there like that, and now you're hands-free. You're going to need to be hands-free for this so you can do manipulations. All right, now what you're going to do to start out with is you're going to create this mixture of silver chloride and lead chloride in the same tube. So you're basically going to make a mess of things deliberately. And again, you need to follow the directions. So you're going to put in 3 drops of silver nitrate. All right, and then we're going to need, what do I say there? We need 6 drops of that's correct, right? 6 drops of the lead nitrate. So we're not shooting anything into this. We're actually counting drops and being careful. All right, and then what we're going to do next is, in chemistry, what we call essentially a titration. We're going to add 6 molar hydrochloric acid to this sample, 1 drop at a time. We want 15 drops. And if you accidentally go over like 1 or 2 drops, that's not a bad thing. So don't sweat that part of it. But you don't want to be under. And what we're doing with the hydrochloric acid is we're going to now literally precipitate both the silver and the lead. So we're going to make a solid silver chloride and lead chloride, lead 2 chloride, out of both the lead cation and the silver cation. And we want an excess of the hydrochloric acid because we don't want any of the silver ion or the lead ion to not be made into the solid. All right, 15. I think I got a 16th drop in there. Now, you want to mix this. Make sure it's mixed up well. All right, and if you do get 6 molar hydrochloric acid or the nitric acid on your hands, what's the procedure?
Wash it.
Yeah, there's soap over there. Wash your hands and then you can continue. All right, now what we're going to do next is utilize the centrifuge. So you're going to be doing a lot of transfers. You're going to be transferring from the test tube into an Eppendorf tube, and you're going to be going back and forth. You're going to use one Eppendorf tube for this, not more than one. And when you guys actually start working, I will just have a handful of these tubes that are sitting out on the bench for you to have access to. So I've already pre-rinsed my pipetter, and all I'm going to do is go in here and remove all of the material from the tube and place it into my Eppendorf tube. Alright, now, whoops. I actually contaminated my distilled water, so what I'm going to do is rinse this out really quick. Alright, I'm going to dump this. Seal my tube, and when it's sealed you can set it down on the bench. I'm going to rinse my beaker out really quick and replace the distilled water. Okay, now I also will make sure that there's Sharpies out on the bench. Do me a favor and don't take them, alright, because I've had problems with that before. They'll be out on the bench for you to mark your tubes. You're going to need to mark this tube some way. I'm just going to use an X on mine today. So now what we're going to do is centrifuge next. You got to, like, now is where you're going to need to pay attention. The tubes have to be balanced. So what you're going to do is, and I'll have balanced tubes sitting out next to these, you'll open up a balanced tube and you'll add enough H2O to this to equal the level of the other tube, the tube that has your precipitate in it. And then when you put it in the centrifuge, you're going to need the little hinge to be pointed up. And the two tubes have to be exactly in line with one another. Then the lid gets closed, and then you turn this thing on. And this is the way it sounds when it's running properly. I will be able to tell when it's not running properly because this is going to be groaning very loudly. And I'll be able to tell all the way over there on the other side of the room, and then I'm going to be screaming at you not to wreck this thing, alright? So you just need to, like, let it run for 30 seconds approximately. Open the lid up, don't touch anything, let it come to a stop. You can see why you need to have this marked, alright, because this is the balance tube. And then there is a pellet. This is the solid on the bottom of the tube. So what I'm going to do is we're going to pull what we call the liquid that is above the pellet, the supernatant, and we're going to pull that. Can one of you guys go shut that door for me, please? And we're going to discard it. You want, when you pull this liquid, you want to be really careful not to grab the pellet and shoot that into the sink. Alright, then we're going to take distilled water and we're going to refill this, being careful not to disturb the pellet, and we're going to respin it. Just going to check my volumes. Yeah, they should be good. The reason I want to rinse it is I want to be certain that the only thing I have in that tube is the pellet, and any of the material that was in the supernatant has been removed. Alright, and then you can take your pipetter and rinse it. You're going to need to do that because remember what we pulled off of here was 6 molar hydrochloric acid. Alright, so now, what's it say to do next?
Add 1 milliliter of DH2O.
And?
Resuspend pellet.
Okay, so if you look on your test tube, there's actually, or on the Eppendorf tube, there's a 1 mil mark on it. I'll let you guys explore that yourselves when you get there. And so that's about 1 mil right there. And to resuspend, make sure this is closed tightly. You're just going to agitate this. You're going to make a, it's a heterogeneous mixture. Alright, and then what we're going to do is transfer this now, and I'm just going to rinse that again to be certain that it's clean. You're going to transfer this along with all of the solid back into your test tube. Alright, is it back?
Yep.
Yeah. Alright, so now the next part of this is we're going to heat the solution up, and the reason that we're going to do that is because the lead chloride is soluble in hot water. What does that mean, soluble in hot water? Yeah, it dissolves in hot water, but the silver chloride does not. Okay, so we're going to take and warm this up. And you should actually see the precipitate, if you're being observant, it's going to change. So you should just keep your eyeballs peeled on that. We need to get this hot. And okay, so now I have it boiling, and what I'm going to do is transfer it back into the Eppendorf tube. There's still solid in here, yeah, and I need to get all of it out of there. Now this step is pretty crucial. It has to be done hot. You cannot let this cool down, so we're going to respin it. And what should happen now is the only pellet we should have is going to be the silver chloride. Now I have my other tube ready. So I'm going to pull the hot liquid and put it into my other test tube and then set this aside. Alright, and this guy here should be silver chloride if we haven't messed up. And what's in here should be, hopefully it's the lead if I haven't screwed up. And the way we're going to test this now, alright, what are we supposed to do? What's it say to do? 2 to 4 drops of potassium chromate. Alright, potassium chromate is dangerous. You don't want this on your skin, you don't want it on your clothes, and so on, so be careful with it. And we're going to go 2 to 4 drops. We should see a white or a yellow, a brilliant yellow precipitate. Alright, now what we're going to do to confirm the silver chloride is first we're going to dissolve it in ammonium hydroxide. So I want to make sure this tube is clean, so I'm going to rinse it really quick with distilled water. Alright, and I'm going to take my ammonium hydroxide and I'm going to add, what did I put in there? 3-4 drops? What did it say in there? So So 2 to 6, so I'm at 4. So I'm going to mix this up now. You can see I'm being really aggressive with the mixing. And you should see it dissolve like it did. This is pretty good. Alright, so now what I'm going to do is I'm going to take the material from the tube and transfer it to the test tube. And I think I'm going to add a little bit more ammonium hydroxide to this so we have a little more volume. Alright, and you can see that's pretty colorless. Alright, that's pretty good. Now what we're going to do, and look at this, see, over time that's starting to solidify pretty good. We're going to titrate now with 3 molar nitric acid. So, just so you have the background, what we did here was we dissolved the silver chloride by forming a coordination complex. So the silver ion reacted with the NH4OH minus, so it reacted with liquid ammonia to make silver ammonia, which is soluble. Now what we're going to do is treat it by titrating with a strong acid, and what that's going to do is titrate away the base and free up the silver ion. What other ion do we have in here?
Silver ion.
No?
Chloride.
We have chloride, and as soon as we titrate the ammonia out of the way, what's going to happen with the silver if I haven't messed up? It's going to react with the chloride and form a solid. Voila. That's positive for chloride. Alright, so we managed to take a solid which contained 2 completely different cations, and then utilizing this technique we were able to actually separate them and then show the presence qualitatively by independent reactions.